at indole, benzofuran, and benzothiophene. Under this session, which is session 1, we are going to focus more on structure and aromaticity of indole, benzofuran, and benzothiophene. So at the end of the session, you should be able to draw structures for indole, benzothiophene, and benzofuran. And then also you should be able to describe the electrophilic reactions of these compounds, as well as being able to describe the Fischer-Indole synthesis as well. So first of all, we will quickly look at the structure of these three aromatic heterocyclic compounds. So indole, benzofuran, and thiophene are heterocyclic compounds that contain 5-membered aromatic rings fused with a benzene, right? So these compounds have 5-membered rings, heterocyclic rings fused to benzene, right? So typically, now this is the common name for the structure known as indole, but it's also known as the benzopyrrole, right? I think we looked at this. So this is the A side, this is the B side. So we can also call this benzo B pyrrole. We can also call this benzo B furan. Also call this benzo B thiophene, right? And then we can also give them this common name as well, benzofuran. Simply say benzofuran. You can also just simply say benzothiophene, as well as just saying indole, right? Now, naming starts from the heteroatom, and any other substituent attached to the ring is located and named in alphabetical order. So it's not so different from how we name or other organic compounds. So we have 2 bromo benzofuran here. We have 1. So we start counting from the heteroatom 1, 2. We have 2 bromo, 4 nitro benzofuran. We have 5 ethyl, 3 methyl benzothiophene. Right. So this is 3 examples for your perusal. You can try naming this yourself. So the first one becomes what? We start numbering from the heteroatom. So 1, 2. So the first one is 1, 2, 3, 4, 5, 6, 7. So we have 1, 7 dibromo benzofuran. This one can also be seen as what? So we have 1, 2, we have 3, 4, 5, 6. So this becomes 2 bromo, 6 ethyl, 3 methyl benzothiophene, right? And the last one can be seen as, can be named as 1, 2, 3, 4, 5. So 2 bromo, 5 nitro benzofuran, right? So these are the names for these 3 structures. So lastly, under this session, we will look at the aromaticity of these 3 heterocyclics. Now they are all aromatic because they are all cyclic, they are all planar, and each has 5 odd pairs of delocalized pi electrons. So without necessarily looking at all 3 structures, you can use indole in this case to explain the pair of delocalized pi electrons present in these 3 heterocyclics. So there are 2, 4, 6, 8, 10 pi electrons. In other words, you can say there are 5 odd pairs of delocalized pi electrons present in all of them. Now, just like pyrrole, in indole as well, it needs the non-bonded pair of electrons on the nitrogen for its aromaticity. So just as we talked about in pyrrole, this lone pair of electrons we see on nitrogen here are delocalized. They are not localized. So they are needed for indole's aromaticity, right? So it helps in obtaining the resonance structures we are seeing here, 5 of them. And some of the canonical forms that are produced through resonance by these 3 aromatic compounds seem to disturb the pi cyclic, the cyclic pi electron system of the fused benzene ring. So out of these 5 resonance structures, you can see that this first one and these 2 have the benzene ring intact. However, in all the others, the benzene ring is not in its complete form, right? Looking at based on the price, so this is not complete, so this is unstable, this is unstable. However, this is stable, this is very stable, this is not stable. So it is this that helps us to indicate the electron donating effect of the heteroatom. So the heteroatom here, and its ability to donate its pi electrons into the ring, is what leads to the formation of these resonance structures. And you'll be looking at their effect in the reactivity towards an electrophile or a nucleophile in the subsequent sessions.